So welcome student. Today I am going to teach you measure of dispersions. In the last lecture we saw measure of central tendency. If you don't saw this video, please go back and watch the measure of central tendencies video. Otherwise you will not understand measure of dispersions. So measure of central tendency is the main part which is most of the question asked in measure of central tendency. So please go back and watch the videos and come back again for measure of dispersion. So why measure of dispersion is important? Today I am going to teach you, so don't worry. So basically what is measure of dispersions? So you can see here is, so this definition is very long, but you can see measure of dispersions are statistical tools used to quantify the spread and variability of a data set. This measure provides insights into how the data points are distributed around the central tendency, helping analysts better understand the characteristics of the data. So maybe you will not understand. So don't worry. I'm giving you my definitions in very simple and layman terms. So you can directly say what is measure of dispersions? It means how your data points far away, far away from measure of measure of central tendency. So I hope you know measure of central tendency. It means mean, median, and mode. These are the measure of central tendency. Yes. So basic definition you can write in the exam. So definitely this question is very important. Sometimes asked in the interview as well or in your exams as well. Like some students are who study like the statistics. So those people you can you should know the definition. What is measure of dispersions? How your data points are away from the measure of central tendency. So let me clear. So I will draw a diagram. So first measure of dispersion is range. So range is actual definition is very simple. Range it means you can see the definition. Range is the simplest measure of dispersion calculated as the difference between largest and the smallest value in the data sets. So range you can directly say range it means the difference between largest values and smallest values in the data sets. So it means maximum value minus minimum value from your data sets. But second point you should add, it is very important. It is outlier sensitivity. What is outlier sensitivity? It means, for example, we have the data of student sites. Yes, student sites in the class. So what is the height? It means like 4.5 inch foot, something like 4.8, 5.6. Yes, I think more than not 6 something. Yes, this is our mostly average height of the students. But if we have some data points like so we have some data points like 100. Is it possible? 100 is the height of the students? No, it is not possible. But these points comes in your data. Then how you can say what is the range? So your range is like 100 minus if you have minimum value is 4.5. So range is I think around 90 95 point something. Yes, 5. Is it possible? So this is outlier. 100 height is the outlier. Yes, that is the we say range is a sensitive to outlier. And based on the range, we cannot directly interpret or we cannot understand the distribution of the data. Yes. So we can go to the next measure of dispersion, which is very, very important. Definitely you heard about variance and standard deviations. So firstly understand what is the variance. Variance, it means average square difference from the mean. It means you have data points. For example, this is our x1 variable. So you have like, you take an example of students marks. Yes, like yes, 80, 90 something, 85. These are the students marks. And if you find the mean, you find out the mean, it's around, I think, 5 to 55 upon 3. So what is the mean? What happened? So, sorry. So it's around, what happened? It is something like this. This is our mean. So we find out the variance. So first what we do, variance formula is, this formula is summation of xi minus x bar square upon, this is our formula, I is equal to 1 top n divided by n. It's our variance formula. So it means these values, for example, our value is 80 minus our 82 something whatever. You can square these terms. Similar, like you can add 90 minus 80, 82 square plus 85 minus 82 square. So whatever value will come divided by your 3. Yes. So you will get the variance value. It means you can say how your values away from the mean. Yes. But it is also sensitive to outlier. Yes. And based on the variance, we cannot interpret, because variance unit is not same, because we are squaring the terms. So our unit is as well square. So So that's the reason we go to the standard deviation. You can say what is interpretability. Variance has a limited interpretability as the units are squared and do not match the original data. Yes, or original data is like in the units, like it's, sorry, it's square, but in variance it is square. Yes, centimeter, it is centimeter square. Yes, this is in the variance. So we go to the standard deviation. So what standard deviation says? Standard deviation is the square root of the variance. Yes, it is nothing different. It is just taking the square root of variance, and it provides the same unit as our original data. Our original data unit is centimeter. The standard deviation is also provides centimeter. That's the reason we just find out the variance and we take the square root as standard deviation. So we mostly use the standard deviation. So for example, so let me clear. If you have distributions like this, for example, this is our normal distribution, yes, and we said this is our mean, yes, it's our mean value. But then you can find out like, yes, this is our first standard deviation, This is our first standard deviation. Yes, is that first standard deviation away from the mean. So this is second standard deviation, this is third standard deviation, this is second, this is third, this is second. Yes, we can say how these data points are away from the mean. Yes, so two standard deviation away, three standard deviation away. So if some points going this side, so you can say these are the outliers. Yes, So go to the next part. So next measure of dispersion is interquartile range. It is just measure the difference between the third quartile and the first quartile. Yes, for example, it means like if you see the box plot, a box sorry, a box plot like this. This is your quartile one. This is your quartile three. Yes, quartile one. So these are the interquartile range Q3 minus Q1. Yes. So guys, so this is our today's lecture. So if you have any doubt, you can ask anything in the comment section. If you like this video, you can subscribe my channel. Yes. So please, if you don't understand, you can give me some suggestions. I will try to make in-depth video. So I think you will understand definitely. So thank you guys.